Okay, so the first thing you understand are position time graphs, and we did a couple of these with the Buggy Lab. And for this one, I'm just going to get a quick sketch. This is 2, 4, 6, 8, 10, and this will be 30, um, yeah, 5, 10, 15, 20, 25, 30. Okay, and then I'm going to sketch out the data. So at 1 second, it was at 10 meters. Or no, sorry, at 0 seconds, it was at 10 meters. And at 1 second, it was at 12 meters. And at 2 seconds, it was at 14 meters. And at 4 seconds, or at 5 seconds, sorry, it was at 20 meters. And at 8 seconds, it was at 26 meters. And at 10 seconds, it was at 30 meters. Okay, so we can graph that really easy. Here you go, it's in that straight line right there. Okay, and then you can look at 6 seconds, he was about 22, 23 meters away from the starting line. So you can see on the graph there, he's that far away. So we could graph this if we wanted to. By looking at he definitely starts at 10 meters, and you can look at the slope of this line, and so he goes from 10 meters to 30 meters in 10 seconds, so that means he goes up 20 meters in 10 seconds, so 2 times t plus 10 x equals 2t plus 10. So is the speed constant? Yes, because we can see the slope here is constant. Okay, now coming over to this graph, another example. Well, we don't need another example. Well, yeah, okay. So, again, 2, 4, 6, 8, 10, 12. And this time, the biggest point is going to be at 12. So 2, 4, 6, 8, 10, 12, 14. So at 0, he's at 0. And then at 2 seconds, he's at 6. And at 4 seconds, he's at 12. And then at 6 seconds, he's still at 12. And at 8 seconds, he's down to 8. And at 10 seconds, he's down to 4. And at 12 seconds, he's down to 0. So connecting those points, we can see there and there. Okay? So what's happening during an interval from 4 to 6 seconds, that's from here to here, well, he got to a certain distance and then he must have stopped. You can see his position doesn't change for that 2-second range. So he must have just stayed there. Okay? What do you think is happening from 6 seconds to 12 seconds? Well, he's going back to where he started. He's going from 12 meters away from, let's call this home, right? Go from 12 meters away from home. He's only 8 meters from home. Now he's only 4 meters from home. Now he's back to home. His average speed from 0 to 12, well, speed is distance over time. And his distance, he goes 12 meters and then stops and goes 12 more meters. So his total distance is 24 meters. And his time is 12 seconds. So his speed then, his average speed is 2 meters per second. Now his velocity is his total displacement over time. So in this case, his displacement from the beginning to the end is 0. And his time is just still 12 seconds. But that doesn't matter because 0 over anything is 0 meters per second. Now you might think, what? That's crazy. How does he have an average velocity of 0 when he's obviously moving most of the trip? But you have to think about, he had a positive velocity at the beginning and then a negative velocity at the end. So when you average those two velocities, positive and negative, they're going to cancel out. Okay, so that's kind of a background of how to do position time graphs, but you also need to know how to do velocity time graphs. So in a velocity time graph, what we're doing is we're taking, remember, we can tell his velocity here by looking at his slope, his displacement over time or distance over time or Or over here, we could look and say his total slope was 20 meters in 10 seconds. So the point is, we talked about this in class, that the slope of a position time graph is the velocity. So when we look at something like this, we can see, well, what is the slope of this graph? Well, it's always the same. What's the slope right here? Rise 1, run 1. So the slope is 1. And from here to here, it's the same thing. And from here to here, it's still a slope of 1. So we can graph that up here. From here to here, it's a slope of 1. When we come down to this one, rise 2, run 1. So rise over run in this case is 2. So for that first second, is a speed of 2. And then rise 1, run 2. So now his slope drops to a half. And that's true for 2 all the way to the end, all the way from 1 all the way to 5 seconds. Is a slope of a half. Okay? And this one we can look here, his slope is 1 and then 1 again. So for those first 2 seconds, he's a slope of 1. And then, as we go from here to here, he drops 2 as he runs 1. So it's a slope of negative 2. And he does that for 2 seconds. So he's down here at a slope of negative 2, a speed of negative 2. Remember, here's 0. So here's positive 1, here's down to negative 2. As we come to this fourth example here, for the first second, we have a slope of, remember, drop 2, run 1, so slope of negative 2. And then he doesn't move, right? His position stays at 2 meters for a while. Let's say he ran home, and then he's like, oh, wait, I'm tired. So he sat there for a second, and he's like, crap, I'm late. I got to run home faster. So, but this slope right here is 0. So we show that here. From 1 second to 3 seconds, he's got a slope of 0. And then from 3 seconds to 5 seconds, you can see his slope is down 1 over 1, down 1 over 1. So he's got a slope of negative 1. So he was winded, I guess, and maybe he couldn't run as fast as he was before, but he still knew how to get home. Okay, so you can kind of see how your velocity time graphs work. Remember, what we're doing is we're just looking at the velocity of that line, which is the same as the slope of that line, and we are graphing the slope of that line onto a velocity time graph. Okay, so in this case, we're going to kind of sketch our own from a story. So sketch velocity versus time graph following the description. So the object's moving away from the origin at a constant steady speed. Okay, so since his speed is not changing, let's say his speed is this much. This is qualitative, so numbers don't matter. So he has a pretty average speed, and that speed stays constant or steady. So that means he's going to stay at a constant speed this whole time. This line should be horizontal. Okay, the object is standing still. Well, what's your velocity when you're standing still? If you're standing still, you're not moving. Your position's not changing. So your velocity would be 0. So that means he just stays here at 0 this whole time. He moves towards the origin at steady speed for 10 seconds and then stands still for 10 seconds. So maybe he's away from the origin and he moves towards the origin. So you have to kind of interpret this a little bit yourself. Say, well, is he moving towards the origin from below the origin or from above the origin, right? Is he north of the origin running home? If he's north of the origin running home, that means he's going to be running southward. So he's going to have a negative velocity for 10 seconds. Let's put a 10 right there so we know exactly that's 10 seconds. And then he stands still for 10 seconds, so he's going to be there for 10 seconds, have no velocity. Remember, when you're standing still, you have a velocity of 0 on the velocity time graph. Now we're moving away from the origin. So let's assume again that away from the origin means we're running north. So that means we're going to run with a positive velocity for 10 seconds. Again, we'll mark this as 10 seconds. And then he reverses direction and moves back at the same speed. So since it's the same speed, we want to make sure this distance right here is the same as this distance right here. But since he's changed direction, we have to show that by making it was a positive velocity, now it's a negative velocity. So hopefully This helps you on your homework. If you need to pause and rewind and rewatch this video to understand it, you can do that. Again, you don't need to have the blue homework done before you get to class. You will have time to work on that in class. But try to make sure you understand how these different graphs kind of correspond. Make sure you know the difference between a position time graph and a velocity time graph, or between a story and a velocity time graph. You'll need to be able to create all these different graphs for your homework and for the quiz next time. Okay? Good luck!